In the previous video on quarks, we used the term hadrons and baryons. In this video, we're going to have a look at exactly what hadrons and baryons are. Keep in mind that we're looking at a classification system here, so each of these things has a name, and there's a bit of a hierarchy that we'll eventually have a look at. With hadrons, they are a composite particle, so they're not fundamental. They can be broken down into smaller parts. So hadrons are composite particles. And there are two types of hadrons, and one of those, the term that we've already heard, is baryons. And baryons are made up of 3 quarks. The other type of hadron that we can have is known as a meson or meson, and they are made up of a quark-antiquark pair. So now see that we're starting to get to some of the particles that we're familiar with, and we can start to sort of look at some of the ways that these quarks are grouped together. I mentioned in the last video that we talked about baryon number, and so baryon numbers, as we've already seen, for quarks we know that they have a baryon number of 1/3. Antiquarks have a baryon number of -1/3. And when we then start looking at baryons and mesons themselves, baryons, not surprisingly, have a baryon number of 1 plus 1. Mesons, because they're made up of a quark-antiquark pair, if you consider combining 1/3 and -1/3, they have a baryon number of 0. Now there are a lot of other properties that these quarks and baryons and mesons have, but there's only one that we specifically have to address in IB, and that's the property of strangeness. Now, strangeness is a bit of an unusual one. There are other properties that are similar to strangeness, but like I said, this is the one that we need to address. So it's another property of quarks that then carries through to the hadrons as well. So the property of strangeness is basically just related to the strange quark. So the strange quark has a strangeness of -1. Now you might think, why is it -1? And the reason for that is basically to keep it in line with the electric charge that exists on the strange quark. So because it has a charge of -1/3, its strangeness is then -1. That then means that the strange antiquark has a strangeness of +1, and all other quarks have 0. Now I want to have a look at a few examples of baryons now, and we'll look at both their baryon number and their strangeness. And this is now where we're basically just combining quarks to identify certain properties of the baryons that they form. So we'll start off with, on the left hand side, we'll look at the another sort of table of sorts here. The baryon that we're dealing with, the quarks that it contains, the charges involved, the baryon number, and the strangeness as well. And for each of these are just examples of some of the baryons, not necessarily all of them. So we're only going to look at a few that we're familiar with, and then a couple that we may not be quite so familiar with. So the first baryon that we're going to look at is the proton. The quarks that it contains are 2 up quarks and 1 down quark. So I mentioned previously that baryons contain 3 quarks, and so in this particular case 3 quarks are 2 up and 1 down. Now if you recall from the last video, the charges on the quarks are plus 2/3 for the up quark and minus 1/3 for the down quark, which gives us a total charge of plus 1, which is not surprising considering we know that the charge on a proton is plus 1. Recall again that I mentioned that we should really write the E's after these, but considering that they all have an E after it, we'll just sort of drop that out and ignore it. The baryon number, because these are all quarks, they all have a baryon number of 1/3, which again, not surprisingly, gives the baryon of a proton a baryon number of 1. Now, because there are no strange quarks involved, the strangeness of a proton is 0. Next particle that we are familiar with, or the next baryon that we've already seen, is the neutron. That consists of 2 down quarks and an up quark. Again, if we go through looking at the charge, negative 1/3 for each of the 2 down quarks, plus 2/3 for the up quark gives us a charge of 0, which again is what we'd expect for a neutron, which we know to be neutral. Again, when we look at the baryon number, each of those quarks have a baryon number of plus 1/3, and so we end up with a baryon number of plus 1. Again, no strange quarks involved, so the strangeness is 0. If we look then at the antiproton, so every particle has an antiparticle. The antiproton here is now made up of 2 anti-up quarks, or 2 up antiquarks, and a down antiquark as well. Now the charges here are the opposite to what they were for the quarks, so we'll now have negative 2/3 for each of the down antiquarks, and plus 1/3 for the for the down antiquark. Did I say, get those terms right? So the negative 2/3 for the anti-ups and the plus 1/3 for the anti-down gives us a charge of negative 1. And recall again that the antiquarks have baryon numbers of negative 1/3, so each one of those is negative 1/3 to give us a baryon number of negative 1, which again, not surprising, the antiproton is going to have the opposite baryon number to the proton. Again, no strange quarks involved, so it has a strangeness of 0. I'll leave you to have a look at the antineutron, see if you can figure out what the quarks are that are involved, the charges, the baryon number, and the strangeness in that case. What I'm going to move on to now, though, are examples of mesons. And recall again that they're made up of a quark-antiquark pair. So we'll go through and look at a few examples that you probably haven't heard of, and you won't necessarily become all that familiar with, but some of those that we can link to just so that you're starting to get a sense of how these quarks are combined to form these different composite particles. So again, we'll go through and look at these properties of baryon number, strangeness, and charge. The first one that we're going to start looking at, though, is the don't necessarily need to put the word positive here, but I'll just make it really obvious. It's the positive pion, and it has the symbol of pi with a plus. Now the quarks that are involved here are an up quark and a down antiquark. So the quark antiquark pair there. The charges on both of these, if you go back and refer to the previous video, the charge on the up quark is plus 2/3, and on the down antiquark is plus 1/3. So that gives us a total charge of plus 1. So you can see why the name positive pion. It has a charge of plus 1. The baryon number here, because we're dealing with a quark which has plus 1/3 and an antiquark being minus 1/3, has a baryon number of 0. Again, not surprising, it's not a baryon, so it has a baryon number of 0. no strange quarks involved, and so its strangeness is 0. The next one then is the positive kaon, spelt K-A-O-N. The symbol there is a K with a plus beside it. That's made up of an up quark and a strange anti-quark. Again, looking at the charges, plus 2/3 for the up quark, plus 1/3 for the strange anti-quark, to give a total charge of plus 1. So keep in mind again, the strange quark would have a charge of negative 1/3, so the strange anti-quark has a charge of plus 1/3. Again, baryon numbers, we've got 1/3 for the up quark and minus 1/3 for the strange anti-quark to give us a baryon number of 0. Note now though that we've got a strange anti-quark, and because it's a strange anti-quark, it has the strangeness of plus 1. The last one that we'll look at here as an example is the anti-kaon. So I just wanted to sort of vary these examples a little bit so that they're not all nice and straightforward. The anti-kaon is a little bit more detailed, so it's K0, so that should give you some indication about what its charge is going to be, and it's got the bar across it to indicate that it's an antiparticle. Now the anti-kaon is made up of a strange quark and a down anti-quark. Again, the charge for a strange quark is negative 1/3. For a down anti-quark, it's plus 1/3, which gives us a total charge of 0, so an anti-kaon is actually neutral. Baryon number again, plus 1/3, minus 1/3, so notice that for the mesons it's all 0 for the baryon number, and the strangeness here is negative 1 because it contains this strange quark. So we'll leave that there, and next video I want to look at some of the important things about the baryon number and the number that we referred to a couple of videos ago now is the lepton number, and why they're important aside from just being able to give these particles baryon numbers and lepton numbers.